Okay, you guys, this is a race against my phone, all right? I've got 6% battery and I'm too stubborn to plug it in until tonight. So let's see how this goes. Here are two polynomials, boop and boop. Write each expression using the fewest number of terms. Okay. They want me to add q plus r. So there's q and there's r. So they want me to take negative x to the fourth. Oh no. Oh no, I don't have time for my pencil not to cooperate. Crap. Okay, here's another one. Negative x to the fourth plus x squared. Oh my god, this pencil sucks. Plus 2x to the fourth minus 3x squared plus 5. Okay, and then now what I need to do is combine like terms. Sorry guys, that pencil sucks. I can't live like this. Okay, so I have a negative x to the fourth plus 2x to the fourth. That is a positive x to the fourth. You could check by putting negative 1 plus 2 into your calculator. That's a positive 1. Then I have a x squared minus 3x squared. That's minus 2x squared. And then there's that plus 5. Okay? So that's this one. Q of x times r of x means I gotta multiply these two. So let's go to the box, you guys. The box is my new favorite. My new favorite. If you knew me last year, you would have heard me saying a different thing, but this year I love this box. Negative x to the fourth plus x squared. Up here, 2x to the fourth minus 3x squared plus 5. And now we go. This is a negative 2x to the 8th. You guys multiply the coefficients and add the exponents. This is a positive 3x to the 6th. This is a negative 5x to the 4th. And then this is a 2x to the 6th. Negative 3x to the 4th. Notice how the exponents get added and the coefficients multiplied. 5x squared. And now here we are in this box, and we just simplify by putting it in descending order, meaning biggest exponent first. That's a negative 2x to the 8th. Meanwhile, also look for like terms. The next biggest exponent is x to the 6th, but I've got two of them. 2x to the 6th and 3x to the 6th, so that's 5x to the 6th. And then I have negative 3x to the 4th minus 5x to the 4th. That is minus 8x to the 4th. And then I have a 5x squared. Boom. Done. Okay. Here's another always, sometimes, never. Is the following statement always, sometimes, never? If polynomials f of x and g of x have the same degree, then the degree of these two will be doubled. Explain. Let's see. Pick something, you guys. Let's say f of x is x squared. Let's say g of x is, I don't know, also x squared. Or maybe x squared plus x. Doesn't matter. Just two things with the same degree. And now let's add them together. And then also keep in mind that we made these up, so what other stuff could be happening here? I see that x squared plus x squared is 2x squared plus x. I don't see any scenario in which adding two x squareds together is going to result in an x to the 4th, which is what double the degree is a 4th degree. I don't see how that's ever going to happen, okay? So, sorry. I think this one's a never. Okay, Here are two polynomials, bleh and bleh. Write these. Okay, oh my gosh. The subtraction, you guys. Man, on the quiz did I see a lot of multiplication on this problem. There's zero multiplication involved. Okay, we take 2x to the third minus 1, and we subtract negative 7x to the third plus 4x minus x squared. And what we got to do, you guys, minus before parentheses means you got to distribute the minus. And you guys, distributing a minus sign means everybody's sign changes. Watch. 2x to the third minus 1. Okay, also, you guys, after you distribute the minus, drop the parentheses. That's what led you all to multiply. You distributed the negative, you still kept the parentheses, then you thought you have to multiply. Drop the parentheses after you distribute the minus, okay? So watch. Negative negative is plus 7x cubed. This one becomes minus 4x. That one becomes plus x squared. Drop the parentheses. Now, combine some like terms. These guys. Next, I want to put the next biggest term, which is the x squared. And then the minus 4x. And then the minus 1. Okay? That's standard form. That's how we like it. That's perfect. Okay. And now they want me to multiply, which means the box again. Okay. We have 2x cubed minus 1. Negative 7x cubed plus 4x minus x squared. That plus was unnecessary, but you can put it, it doesn't matter. Okay, multiply coefficients, add exponents. So negative 14x to the 6th. This is 8x to the 4th. This is negative 2x to the 5th. This is 7x cubed. This is negative 4x. And this is x squared. Okay. And now we're going to list in descending order. The biggest one is this. Minus 14x to the 6th. Then I'm going to go with the 5. That's the next biggest one. Minus 2x to the 5th. Then I'm going to go with the x to the 4th. 8x4. Then 7x3, then x squared, then minus 4x. Whew, that is a long expression. Okay, here we are. Look at this, they want me to sketch a graph. Oh, how fun. Okay, here we go. X-intercepts, let's list them out. That x right there, it's an x squared. It tells me that I've got an x-intercept at 0 with a multiplicity of 2. I've got one at negative 4 with a multiplicity of 2. And I've got one at 3 with a multiplicity of 1. All right, remember that the multiplicity is the exponent. Now, I also need to understand my end behavior, all right? So to know the end behavior, I need to note that A, it's negative, and that B, let's count up the degree. 2 x's, another 2, that's 4, and another one is 5. So I have a degree 5, which means odd. So an odd negative has an up-down end behavior, okay? Okay, let's go put it all on here. I got an x-intercept at 0, that's right there. I got one at negative 4, that's right there. I got one at 3, that's right there. Now, I also told you guys, I personally want you to also be aware of the y-intercept. So imagine plugging in a 0. And right there we get a 0 and multiply it and everything is 0. There's my y-intercept. I even already have it on the graph. So the y-intercept is 0. So we're set here, okay? Now, my end behavior tells me that to the left I'm up. So right here I'm up. The multiplicity of 2 at the negative 4, 0 tells me I don't go through and I come back up. But I do need to get back to this 0. So I'm going to do something and then come back. Smooth. Remember, polynomials are smooth. No sharp moves. And then that 0 is also multiplicity of 2. So from here, I also need to be a parabola looking thing. So right here, parabola because of the multiplicity 2. Right here, parabola because of the multiplicity 2. Remember, even multiplicities, you bounce. Odd ones, you go through. Okay, then I need to get back to this one. And a multiplicity of 1 here means I go through and I look like a line. I go through smooth. I don't do this little wiggle. And look, I'm honoring the end behavior. This is it. This is my sketch. Okay? All right, guys. I don't know what my battery's at, but let's see if I can get the last 2 done for you before it dies. A function has the following characteristics. The degree is 7. Okay. On the left side, it is going up. So x negative infinity means left side. Positive infinity for f of x means up. On the right side, it's going down. Okay. And it's got some zeros going on. They want me to write 2 possible equations for it. Okay. F of x equals. If it's down up like this, it's positive. So any positive number right here will do. Then we have actually taken care of the fact that it's a 7th degree almost. We need to look at this. And the end behavior. Now let's put these in. Opposite signs. So x plus 5, x minus 1, and x minus 4. But what I have here is a 3rd degree. X, only 3 of them. They said 7th. So I need to mess with these multiplicities until I've got 7 x's. Right now I have 3. So maybe you just want to make that one a 5. Now I have 7 of them. Okay. For the second one, maybe you want to drop a different positive number here, like a 2 or a 12. I don't care. Maybe you want to keep that a 5. Maybe you want to make this a 2, and that a 2, and that a 3. As long as the x's add up to 7, you keep it positive in the front, and these 3 parentheses are here, we are golden. The opportunity, the possibilities are endless. Okay. Now we're dealing with this. Writing an equation that could be this guy, all right? Please note that it's ending down. That makes it negative. Don't forget that negative. The little details like this, you guys, I write it down immediately. Because I know once I'm busy thinking about what all of this means, I will no longer remember that at the end of all that. So I got the negative there. Now I notice there's a 0 at negative 4. There's one at negative 1. And there's one at 3. So I have x plus 4, x plus 1, and x minus 3. I am not making a mistake here, you guys. You gotta do the opposite signs. Okay. And now looking here, and here, and here, I'm noticing they're all bouncing. They all look like little parabolas in their little areas. So I need even multiplicities for these, at least 2. Now, you could put a 4 if you want, or a 6, or whatever you want. However, it needs to be at least 2, okay? And that is one possible equation. That's it. We did it. I wonder where I'm at battery-wise. Good luck, you guys.